Look up at the night sky and you will see it, our closest celestial companion, the moon. For billions of years, it has silently orbited Earth, a seemingly unchanging sentinel. Its surface, scarred by countless impacts, tells a story of an ancient violent past. But the moon exists in one of the harshest environments imaginable, the vacuum of space. Unlike Earth, it lacks a protective atmosphere, a thick blanket of air that shields us from sun's fury and the cosmic bombardment. It doesn't have a global magnetic field like ours, which deflects the dangerous radiation. So, if that is so exposed, why isn't the moon slowly eroding away? Why hasn't it has been completely stripped bare by the constant onslaught of the solar wind, micrometeoroids, and cosmic rays? This is a question that that puzzles scientists for a long time, and the answers are from fascinating then and you might imagine. So today, join us as we uncover the incredible hidden protection that allow moon to defy the cosmic storms and stand as a testament to the celestial resilience. To understand the moon defenses, we first need to understand the threat it faces. The most significant of these is a solar wind. Imagine a constant supersonic stream of charged particles, protons, electrons, and helium ions continuously emanating from sun's scorching corona. This solar wind travel at the speed of hundreds of kilometers per second, bathing everything in the solar system. When these high energy particles collide with planetary surface that lacks the protection, they can literally blast atoms off the surface. This process is called sputtering, a slow but relentless form of erosion. Over billions of years, sputtering could be, in theory, strip away significant amount of material. But the solar wind isn't the only aggressor. Moon is also constantly bombarded by the micrometeoroids, tiny grains of dust and rock, often no bigger than a grain of sand, traveling at an incredibly high velocity. These aren't the large asteroids that create the giant craters, but collectively their impact causes a process known as the impact gardening or regular churning. Each tiny impact pulverizes the surface and the material contributing to the erosion. But then there are cosmic rays also. These are incredibly energetic particles, often atomic nuclei accelerated to nearly the speed of light by the supernovae and other violent cosmic events. While not as significant in terms of the direct erosion as a solar wind or micrometeoroids, they contribute to the space weathering and can alter the chemical composition of the surface. So the moon is under a triple assault: the steady hiss of the solar wind, the drumbeat of the micrometeoroid impacts, and the silent penetration of the cosmic rays. It's an environment where most unprotected surfaces would vanish over eons, yet the moon persists. How? That's a big, profound question. The first and the perhaps most fundamental protective mechanism isn't some exotic force field, but something far more commonplace: the lunar regolith, or in other words, the lunar soil. This isn't just an ordinary dirt, it's a pulverized, fragmented layer of rock and dust created over billions of years by the very impact we just discussed. It ranges in thickness from a few meters to tens of meters across the moon's surface. Think of the regolith as a deep, porous, shock absorbing blanket. When the solar wind particles or the micrometeoroids hit the loose granular material, they don't encounter a solid uniform surface. Instead, they plunge into the depth of the countless tiny particles and the void it creates. This porous nature has several key advantages. First, The impact energy of the micrometeoroid is dissipated across many small grains rather than concentrating on the solid point. Second, while individuals regulate gains to get eroded by the solar wind spurting, they are also constantly being mixed, turned over, and replaced by the new material from the deeper layer due to the ongoing impact. It's like a self replenishing protective layer. This process is called gardening, means that while the very top layer is constantly changing, the bulk of the regolith act as a buffer. It efficiently absorbs the energy of the incoming particles, preventing them from penetrating deeper and eroding the underlying bedrock. It is a brilliant passive defense that has evolved over billions of years of the bombardment. The very dust that made walking on the moon so challenging for astronauts is an fact one of the greatest defenses against the cosmic erosion. It's a testament to how natural processes can create elegant solution in the most extreme environments. Now let's explore more enigmatic form of protection, one that hints at the moon's fiery past, the ancient lunar magnetic field. Today, the moon has no global magnetic field. Its core has largely cooled and solidified, meaning it no longer generates the powerful magnetic dynamo that protects Earth. However, scientists made a remarkable discovery. Certain regions of the lunar crust exhibit strong localized magnetic field. These are like fossil remnants. The moon did have a powerful magnetic field, perhaps billions of years ago, when its core was still molten and active. These localized magnetic fields, often found associated with mysterious bright lunar swirls, act like tiny scattered force field. When the solar wind encounters these, mini magnetospheres, some of its charged particles are deflected, creating a magnetic bubble that shades the surface directly underneath. What is fascinating is that the regions covered by these mini magnetospheres show less evidence of this space weathering and erosion compared to the surrounding areas. This suggests that these ancient magnetic echoes are still providing a measure of protection, literally leaving their mark on the lunar landscape. The brighter appearance of the lunar swirl is thought to be a direct consequence of this reduced space weathering. Less bombardment by solar wind means surface gains are less darkening, maintaining their brighter initial color. It's like scientists, finding fingerprints of the bygone era, showing us where the moon ancient magnetic shield once held sway. While these mini magnetospheres are not a global shield, they demonstrate the enduring legacy of the moon's internal geology and its surprising ability to retain the protection from its deep past. You must be thinking, but the moon has no atmosphere, and you would largely are correct in traditional sense. It doesn't have a thick blanket of gas like Earth, capable of burning up the meteors or sustaining life. However, it does possesses an incredible tenuous layer of gas, so thin it is called an exosphere. This exosphere is primarily composed of gases released from the moon's interior, such as radon or argon, or generated by the interaction of the solar wind with the surface, like hydrogen and helium. These gas particles are so spread out that they rarely collide with each other, constantly escaping into space or falling back to the surface. While not a shield in a robust sense of the Earth's atmosphere, comparatively, this exosphere plays a subtle role when the solar wind particles strikes the moon. Some are implanted into the regolith, while others are reflected or re-emitted as a neutral atom. These are these are particles combined with other exospheric gases form a very diffuse cloud that can, to a tiny extent, interact with slightly modified the incoming wind. More importantly, the very process of solar wind hitting the moon's surface causes some of the solar wind particles themselves to be neutralized and reflected back into the space. This isn't a protective mechanism in the sense of stopping the wind from reaching the surface, but it's a part of dynamic interaction that sees a portion of the solar wind energy and particles bounced away rather than fully absorbed. It's a complex dance of interaction rather than a solid barrier. So, while the moon exosphere doesn't provide the robust protection of a dense atmosphere, it's a highlight that the intricate ways even the most seemingly barren celestial bodies interact with their space environment, and every atom and particle counts in the grand cosmic ballet. So, we have explored the moon's surprising area of defenses, its resilient regolith, echoes of ancient magnetic field, and its dynamic, if tenuous, exosphere. But why is understanding these mechanisms so crucial for us here on Earth? The answer lies in our future ambitions. The humanity is poised to return to the moon, not just for the fleeting visit, but to establish a long term base, conduct scientific research, and perhaps even extract resources. For these endeavors, understanding space weathering and erosion is paramount. Astronauts and equipment will be exposed to the very same solar wind and the micrometeoroid bombardment that the moon has weathered for eons. Knowing how these natural environment behaves help us design more resilient habitat, protect sensitive electronics, and even plan for the long-term degradation of the material like solar panels, etc. The regolith, while a natural shield, also present a significant challenge: lunar dust. It's an abrasive material, electrically charged, and gets everywhere, posing risks to machinery and human health. But understanding its formation and properties is important. How it's created by erosion also opens a new door. Perhaps we can use this very dust as building material, turning a threat into a resource for lunar habitats. Furthermore, by studying how different parts of the moon have been eroded or protected, scientists can gain deeper insight into the moon's geological history, its internal evolution, and even the history of the sun's activity over billions of years. The lunar surface acts as a cosmic time capsule, preserving clues about the past that are lost on Earth due to our active geology and dense atmosphere. Every piece of knowledge about lunar erosion brings us closer to making our lunar future a reality, ensuring the safety of our astronauts and the success of our scientists' endeavor. From a distance, the moon appears serene and passive, but beneath its seemingly unchanging facade lies a dynamic battleground, a testament to cosmic resilience. Our nearest neighbor is not simply a lifeless rock enduring the harshness of the space. It actively and passively protects itself. Through the ingenious simplicity of its pulverized regolith, the ancient echoes of this magnetic past, and the subtle interaction of its tenuous exosphere, the moon has developed its own invisible armor. It's a marvel of the natural engineering forged in the fires of the early solar system and refined over eons of bombardment. The next time you gaze up at the moon, remember its incredible story of survival. It's a silent guardian, a cosmic survivor, and a testament to the myriad way of celestial bodies adapt and persist in the vast, unforgiving expanse of the universe. So, friends, thanks for joining me on this journey to uncover the moon's hidden protection, If you enjoyed this exploration of lunar science, please like this video, share it with your friends and family, and subscribe our channel for more cosmic discoveries. See you in the next one.